Thanks, Callie. We'll get into it a little bit more today then. Yep. Plus or minus 1, 2, 4, and we're dividing by 1, so happy day, this is really nice, right? Is everybody there with me? Okay, I'm going to do the Stark's rule of sign. How many sign changes do I have with my coefficient? I have 1, 2, 3, 4. So I have 4, 2, or 0 positive zeros. Now, how does that help us? Now, you might be saying, I don't know. But if you find at least 1 positive 0, what does that mean? You know there's at least 1 more, because there has to be at least 2 if you find 1. Does that make sense what I'm trying to say? If you find 3, you know there's at least 1 more. It has to be 4. It has to be one of those things. Could you be searching and have none? Sure, that sucks, but it is what it is. Okay? Okay, once again, how do I find the negative? First off, is everybody okay with understanding what Descartes' rule of sign for positive? Just count the sign changes on the coefficients. Anna, does that make sense to you? Everybody else? Good? All right. Here we go. Now, by the way, when you find the negatives, you replace the x with what? Negative x. Who's the only coefficients that are going to change?
The odd.
Just the odd powers. Because even powers, what's a negative square? Comes out to be positive, it would not change the coefficient, would it? But what is a negative raised to an odd power? It will come out to be a negative, so therefore if it was negative previously times a negative, that becomes a positive. If it was a positive times a negative, that becomes a negative. It will change, won't it? So therefore, what would be the coefficient on x to the 5th? Is he positive or negative? Negative. And this is all I do. I just put a negative. X to the 4th, is he going to stay positive or negative? He's still going to stay the negative because he's going to stay the same. Because it's an even power. Because I'm plugging negative x. I'll show you if you need me to. You want me to show it to you? Really quick, it's just negative x to the 5th, which becomes negative x to the 5th, right? That's where that came from. That's the rule. That's the rule of how to find the negative zero. You just replace x with the 5th. So therefore, this one's going to come out negative or positive? Positive. What about that one? Positive. What about that one? Positive. What about this one? So I go negative, negative, positive, 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 right? Does everybody understand where that comes from? How many sign changes? 1 sign change. Ethan.
So, find 1 sign change and then that can't be anything.
Nope, so it's just, we know for sure we have 1 negative 0. We know that for sure. It cannot be 0. We know for sure there's 1 negative 0 in there. Okay, that helps us find our negative zeros. The first thing, if we just look at the equation, that helps us find the positive zeros. If we look, well, now I remember our story we talked about. Nothing. So therefore, to find the negatives, I replace the x with negative x. Does that make sense, Callie? And then therefore, that's where all I care about is the signs of the coefficients. I don't really care about the equation because that's what I'm looking is counting sign changes. So I just put negative or positive there to say who's going to change. Okay, 1 negative, 4, 2, 0 positive. Yes, no, maybe so. Okay, there's 2 negatives, but did it change from a negative to a negative? Did my sign change? Changed this 1 time, right? Okay. So when I go through this now, does that mean that this is going to be one of my numbers? Is negative 1, negative 2, or negative 4 for sure going to be one of my zeros? No. It could be, once again, an irrational number, right? Does that make sense? Does that count as a negative number if it's like negative root 3? It would, huh? It still counts. I'm not that mean, though. So hi. Yes, ma'am. That counts. No, that does not. That counts as 2. I had to think about your question. What's the first goal we always do? Add it to find, to see if, who would be, if it comes out 0, who is 1?
1.
Okay, here we go, negative 1 plus 1.
0.
All these guys are opposites, right?
Yeah.
So therefore they're gone. So therefore we know for sure 1 is here. We go through it. Be very careful. As I was looking at your test, some of you guys miss a sign. If you miss a sign, that messes you up, correct?
Yeah.
Be very careful. 1 down. 1 times 1, 1. 0. Don't play with the lights, guys. You gotta have them working. Hey, Cody Caesar. Not really. That was rude. Shouldn't do that either. No meaning. I gotta quit the college stuff. That's true. See? Messed up. My mind went other places. Did it go into it? Yes. It proved that it went into it, huh? Thank you. Okay? Add them up again. Because what if 1 goes again? Can 1 go, like she said, multiplicity?
Yeah.
So quickly check. 1, negative 3, negative 4.
No.
Didn't work, did it? So now we think, okay, but notice we've got 1 positive. What does that tell us? We got to have at least 2, so there's 1 more in there, huh?
Yeah.
But, can anybody tell me why I'm not going to do this any longer? I'm not going to do synthetic anymore. How do I know I can factor? I don't have an x squared.
It's an x forward.
I have x to the 4th minus 3x squared minus 4. This is one of those u substitution ones, correct? Can we see that? Michael, it looks like you're a little frustrated with these. Hard to see those things. Could you keep going? Sure you could. We could keep going down these guys, couldn't we? And still look for them. But if you see something familiar, hopefully this by now, like I said, I know you just tested on it, but it's familiar to us supposedly. I understand it's a supposedly. Okay? So I do a little u substitution, or you don't even have to do a u substitution. You just say, okay, 1 times negative 4, negative 4. Factors of negative 4 to get to negative 3. Negative 4, negative 1. I mean positive 1, right? Correct? Everybody see where I got there? Did I even have to do u substitution? I don't really have to. The reason why I do it is so that you visually can feel comfortable. Because right there, you guys still uncomfortable, right? Hence why I said over here, x squared is u. Then I can say u squared minus 3u minus 4. You're like, oh, that's u plus 1, Mr. Roberts, and u minus 4. You feel comfortable there, right? Hence, if I replace that, then now with the x squared, I get exactly back to here. It's just a way to make you feel comfortable. Do you have to? No. Okay? As you do it more, you won't have to do it as much, right? Does that make sense? Okay. Can this guy go any farther? We could. We just learned how to do it, right?
Yeah.
This goes to x minus I, x plus I, and how do I know that? Because this guy right here is the same thing as negative I squared, so that's a difference of squares, right? What's I squared again?
Negative 1.
Negative 1. Negative 1 times a negative becomes a positive 1. Okay. What's this guy?
X minus 2x.
X minus 2x plus 2. Awesome. Because hence they are difference of squares. Hopefully, difference of squares is going to pop up a lot. So hopefully you're just going to on those things. Jump on. Okay, and who else was one of my factors? Because what if I want you to write it in factored form? Over here, right? Where did he come from? That guy right there. That's considered factored form. Now, actually this, if I left this as x squared plus 1, that's also considered factored form. But if I ask for factors in linear fashion, or what the heck does it say? It says, please have your factors be linear factors, I think it says. These are linear factors because it's ax plus b or mx plus b, right? Does that make sense to everybody? Okay. What are my zeros?
1, 2, I,
somebody said, and plus or minus I, right? Now, let's go back to what our Stark's rule of sign said. How many positive zeros came up? 2, because I had 1 and I had 2, correct? How many negative zeros came up? 1, which was the negative 2, correct? And then we had 2 complex. That got us to our 5. Notice 2, 1, plus 2 more, got us to our 5 as well. Okay? Could 4 plus 1 get us there?
Yeah.
What if nothing came out? What do you know? How many complex roots do you have? 4. You got 4, right? Because I'll have 1 negative and 4 complex roots. Everybody understand where I'm going with that? You see why this is helpful? Maybe on this one you don't see it. But what if all of a sudden this one comes up with 0 negative? You'll never have a 0 negative. That just cut your choices in half, didn't it? That's why it's useful, right? Cut those choices in half for you sometimes. How I did what, excuse me? Okay, so Descartes' rule of sign, remember, if you're counting the sign changes, that's a sign change. 1, sign change. 2, sign change. 3, sign change. 4. There's 4 sign changes. So therefore, I go from 4 to 2 to 0. I got to go down by powers of 2 because once again, complex numbers come in conjugate pairs. 4, 2, or 0. It's important to say 4, 2, or 0. Just remember on the turning points, I was nice, but still on the turning points it should have been 5, 3, or 1, or 6, 4, and 2, or 0, right? You guys remember that? I was nice on the test though. Yes, Hannah? Yeah, shouldn't I have 5 zeros? X to the 5th, right? Does that make sense to you? Nope, I didn't even have 3 positive. I had 2 positive, negative 2, 2 and 1. There's 2 of them. Negative 2 was a negative 0. And then I had 2 complex. I'll scroll down and show you though. Positive, positive, 1 negative, and those are complex. Even though that's a positive complex, that's still a complex or imaginary number, right? Answer everybody's question? You doing okay? Okay, next slide. We can handle the blue, can't we? We can't handle blue? We can't handle blue. No, we ain't touching gray. Oh my goodness. We can handle gray. Let's go with some gray. Looks a little darker. I don't like darkness. I like the light. Somebody asked me to, you dingleberry. What do you think? All right. I do. They don't hear very well. I called Ethan a dingleberry. Now it's on there just for you, brother. Okay, here we go. So let's do everything once again. This time use a graphing calculator to help us find some roots. So right now, beforehand, I kind of just hold off. Just whoa, everybody. Whoa, Betsy. Betsy was my horse. She was a nice horse. She was the one that, yep, she's the one that ate me out. Did I tell that story too? Man, that's horrible. I tell a lot of the same story. Here we go. First off, I want to do Descartes' rule of sign. I want to emphasize that a little bit better. Okay? How many positive zeros am I going to have? 1. I am going to have, because of this sign change right there, I'm going to have 1 positive 0 for sure. Everybody there with me on that? There's going to be probably a question on your test using Descartes' rule of signs. How many possible zeros are negative? So you need to understand these, okay? How do I find the negative 0 possibility? Change everything. Change the coefficients and then look for the sign change, right? X to the 4th, is his coefficient going to stay the same or switch? Stay the same, because it's x to the 4th. X to the 3rd, is he going to stay the same or switch? Switch. X to the squared, stay the same or switch? Same. Switch. sign changes? We have 3, so notice we're going to have 3 or 1 negative. So at least we know that we're going to have 1 negative and 1 positive for sure. And notice if we found those and they were rational zeros, we could at least get down to a quadratic, couldn't we? Hate it.
Why is it 3 zeros?
Because once again, I need to have a total of 4 zeros, right? So if I have 1 plus 3, that's 4, and that's how many I should have to the x to the 4. But what if I have complex zeros, right? How many do they always come in? 2. I already know I have 1, there's 3, so therefore how many negatives can I have? 1. So you're always going to drop down by 2 just in case if there is complex zero. Does that answer your question? Okay. Everybody good on that? Okay, so now, please find your calculator. I'm going to put. Okay, so he's going to go ahead and do this. There's a 3. He's doing his math. Plug along. Gee, yeah, you're right. Okay. I love to see kids do math.
Thank you. Okay, okay, don't tell me anymore.
Oh, you might have needed your help there.
I almost did.
Okay, awesome. Now, on your graph, guys, how many of you guys probably saw the whole graph when you graphed it? Good, Hannah, good job. Everybody else just saw where they crossed the 2 things? Just kind of went, ah. How do I know there's not more zeros? Well, this right here proves there's no more zeros to the right of 3. Why? You guys remember there's no sign change. Because there's no sign change, therefore I know there's no more larger numbers. And that kind of makes sense because I have how many positive zeros? 1, so I should know that there isn't any more, right? Does that make sense? Hey, James, come on up. Now, James, am I going to go off these top numbers or am I going to go off the bottom ones? Bottom ones. You might as well keep going off the bottom ones, because that was an x to the 4th. Now what is it? X to the 3rd. What's the other zero we're going to use? Negative 3, because we found both of them. Okay, why would that? Yes, you can, but why would that be not very good? Because then it just gets you back down to an x cubed again. How are you going to find the other 2 that you need to find? So if you keep going down, it can always get you down to a quadratic, which then what can we do with quadratics? Factor or quadratic formula. Does that make sense to you, Bryn? That's why it's important to go off them. Did you do something wrong? This is a positive one. So just that one sign made him off a little bit, right? Nothing, not that he didn't know how to do the process. It's just he was off by a sign. Okay. See, you see how they're standing straight on? As a teacher, do I really ever stand straight on? I'm a side rider. That's why you kind of go up and down a little bit on an ankle. 2. -6. Thanks, brother. Okay. Once again, we went x to the 4th. What's this guy right here? X cubed. What's this guy right here? X squared, which is nice. So this tells me x squared plus x plus 2. With that being said, what can we do? We can not factor this one. This one's a quarter. X equals opposite or negative b, whatever you want to say. Plus or minus square root of b squared. That would be, I'm really lost what? Minus 8 all over 2. 4 times 1 times 1. I mean 4 times 1 times 2. So that's negative 1 plus or minus I root 7 over 2. Enter. What? No, you're good. Don't worry about it. I'm asking you to hand out some, Kelsey, I got your test right here. this out. We're going to go one more. Ethan.
So if we were to put that x equals
So if you're asking to go into linear factors,
I love
right?
math.
How would he do this as a linear factor? This number right here, you'd go x minus parenthesis negative a half, negative 1 divided by 2, plus I root 7 over 2, parenthesis. Does that make sense? And then the other one would be parenthesis x minus parenthesis negative a half minus I root 7 over 2, parenthesis. That's how you do them as linear factors. Okay, so let me ask you this question, okay? So if I had 2 and negative 2, I'm going to show you exactly what I just did here. Okay, exact same thing, and I think you'll understand now. So here I'd go x minus 2. Here I'd go x minus a minus 2. What does the minus become? So if you always do the minus, because we don't want to change this. That's not the conjugate part. This is the conjugate part. Well, as soon as I distribute it through, I would. I haven't distributed it through yet. Oh, why don't I change him? Because he's always consistent. He's always that number. Does that make sense? So it says here, use the turning points to explain why the graph does not show all the real zeros of the function. Okay, so notice I have a real zero here and a real zero here. How many zeros? 2. Okay, so there's 2 real zeros. Right? It has 1 turning point, 2 turning points, 3 turning points. Okay? So there, whoa. Okay, so I have 3 turning points. Notice, this is x to the 5th. That's exactly why I just said whoa. How many turning points can there be? 4, 2, or 0. So therefore, that's the question. How do we know it's not showing all the zeros? Because all we have is 2 real so far, right? We can imagine 2 of them being what? Complex. That would be okay, wouldn't it? So that's up to 4. I'm still missing 1. So therefore, I don't have all my real zeros yet. By using my turning points, right, plus it's next to the 5th, I know I don't have all of it. And end behavior of x to the 5th, that looks like an x to the 4th, doesn't it? You guys see what I'm trying to say by that? So it doesn't have the whole viewing window. So it's a thinking question, right? Are you understanding everything we're putting together? Okay? The graph, so here's f of, okay. So, if I have this exact graph right here, it says the graph g of x equals f of x plus 4 is a translation of the graph up here, up 4 units. What does that do to this thing right there? It moves it up 4, so therefore I have my y-intercept at 0, 0 now, don't I? Okay? And then notice it says, how many real zeros of g will the graph of g show? It'll show another one because it'll have it at 0 as well, right? Because it takes this point right here. You'll still have one like this. It'll look like this. But here is my axis. So it'll have 1, 2, and 3 right there. You see how that shift up would make that graph go right to there? Because that's a 4 technically. That's just kind of thinking. Yeah. No, you'd have 3 of your zeros and then probably 2 are complex. Okay, how do we graph this guy really quick? Because I didn't get to that. We've done it in the past. We put him on our zeros, right?
Yeah.
So I'm at 3. 1, 2, 3. Negative 1, 2. It's a cubic. How do I know it's a cubic? Because if I went x times x times x, that is x to the 3rd. What's my end behavior? Ba-doom. How do I know that? You're still struggling with end behavior? Let's talk then. Okay. If you're struggling, I saw some people struggle, so if you need it, that's important. That's how you do these graphs. So the end behavior says I'm going to go here, here, here. I'm not bouncing because I don't have any even multiplicity. Right? Okay. Appreciate you guys.